Good morning, lovely Niners. Right, buddies, we are continuing. Oh, we're not continuing anything. We're starting a brand new unit today. How exciting, my buddies. So I hope that you like constructions, and I hope that you liked bearings and all of that really good stuff. But yeah, we have to move on to something new, which is also amazing and exciting and amazing, so you should really enjoy it. Your title for today is Standard Form. Now, you may well have heard about this before from your science lessons, okay, buddies? That'll be where standard form has entered your mind before. And pretty much what it is it's a way that you can represent really, really big numbers or really, really small numbers without having to write millions of zeros. So, for instance, I put this picture of the sun on there because I wanted to remind myself to tell you about this. But pretty much, the distance between Earth and the Sun is 150 million kilometers. Okay, so let's say that you were an astronomer and you had to keep writing that 150, 1, 2, 3, 4, 5, 6, 150 million kilometers. Now, if you're a scientist, actually, kilometers isn't the base unit, but meters is. So you'd go 1, 2, 3 more and you'd make it meters even. Now, let's just say that you were doing a project or you were doing some research on the sun and it mattered how far away the Earth was. And let's just say you had to use this number with all those zeros in it over and over and over and over again. Well, I can assure you that your hand is going to get pretty tired of that pretty soon, and so will you get pretty tired of that pretty soon. So essentially, we need a better way to write stuff that has lots of numbers. Now that's only the Earth to the Sun. You could go way bigger distances than that. If you were to say how wide a galaxy is, that's an enormous distance. If you wanted to say how far it is away from our galaxy, say the Milky Way galaxy, to a different galaxy, say the Andromeda galaxy, well, that's even bigger of a number still. And if you want to get there's all sorts of cool stuff. There's things like galaxy clusters, which are like families of galaxies together. And there's all of these things are vast, my buddies, like vast, vast. And so we don't want to be writing out millions of zeros at the end of the day. So what do we do to avoid writing out millions of zeros? Well, what we do is we invent a notation, and here we go. This here, instead of writing 1, 5, and then 1, 2, 3, 4, 5, 6, whatever I'm trying to say, 1.5, oh, sorry, my lovelies, times 10 to the power of 3, 6, 9, 10, 11 would be the distance from meters. Will be the distance from the Earth to the Sun, which is a lot better, my buddies, than actually writing out that many zeros. It was a lot easier to write. There's less errors to be made because it is, there's fewer zeros. There's less errors to be made. Whew, sorry, I'm struggling over my words today. And here we go then. Just so you guys can see how that works, check this out. There's an awesome way of doing every single one of these questions. So 8,000, you probably wouldn't want to use standard form for 8,000 because it's just an easy number to write anyway. But if you wanted to write this in standard form, here's what you do. Instead of 8,000, here's what you always do. You start off by putting the number to begin with. So you put 8. And then you're going to go times 10 to the power of, because remembering, each time you times by a power of 10, it adds an extra 0 on. So if I said to you, what is 2 times 10? Well, it's 20, because you added an extra 0 onto the 2. But if I said what's 2 times 1,000, it would be 2,000, because there was 3 zeros in 1,000, and you put all 3 of them onto the 2. So that's why we have to use these powers of 10. That's why we do that part. And if you check it out, there's 1, 2, 3 zeros in this, which means it's times 10 to the power of 3. Bish, bash, bosh. That's standard form. Cool. Next one here, here's what you're going to do. New rule is when you've got two numbers that aren't just a 0, you can rewrite it like this. You write 9.7. So the first number should be a non-zero number, and then whatever else goes after the decimal. It's a bit like rounding to significant figures. So this one here will be 9.7 times 10 to the power of, well, 1, 2, 3, 4, 5, 6 times the decimal has to move. So times 10 to the 6. And finally, this one, what do you think it is? Well, if you said 4.25 times 10 to the 1, 2, 3, 4, you're absolutely right. So good work, Super Nines. Okay, cool beans, buddies. Without even my help, I want to see if you can do this. Go. Switch them back to ordinary numbers this time. Okay, and now that you've switched them back to ordinary numbers, let's see how you've got on. This one here, you'll simply put 4 zeros on the end. 1, 2, 3, 4. So this number is actually 60,000. This one here, you're going to put 5 movements, okay? Now here's what I'd say. You're going to go once, 2, 3 times to get the decimal there, but then it has to go 2 more to get the decimal there, which means you need placeholder zeros, which means this number is 834,500, which is 834,500. Now, that's how you should actually, well, that's just how people think about it, but I've got a tidier way. Are you ready for it to a bit tidier? I am. Okay, 834,500 is the answer. Here's how I like to consider them. Here's what I do. Starting at this, the decimal point, 3 spots to go here. 1, 2, 3 to get it after the 5. That leaves 2 zeros. So the answer is just going to be 834,500, which is 834,500. Same number as last time. Times 2 this time, it's just 2 spaces in. 978.98. 0.98, I should say even. 1, 2. Ends up there. Cool beans, buddies. So it's not too bad. I hope I've not gone too quick, but I hope I've gone the right speed, but you'll tell me, I'm sure, if I haven't. And here's what I'm going to get you guys to do. I want you to just do the top half of a worksheet, which is going to be attached. Actually, no, it's not going to attach. I'm not going to attach it. I forgot about that. I'm not going to attach it. I want you in under 5 minutes, so you can do it. I believe in you. Under 5 minutes to finish the whole of this sheet. You're just converting form, okay? So push pause, finish the sheet, go. Okay, buddies, so let's see how we got on. I think I'm going to do this verbally in the interest of not making this video be way too long. So let's do it verbally. So get ready to tick across your answers. So now that you've written all of these answers down, have a different color pen out, or even your same color pen. I don't mind too much, but different looks better. And here we go. First one, you should have just had 7 times 10 to the 5. For B, 6 times 10 to the 2. C, 2 times 10 to the 3. D, 9 times 10 to the 8. E, 8 times 10 to the 4. Write these as ordinary numbers. This will be a 6 followed by 5 zeros. Okay, that's 600,000. This will be a 1 followed by 4 zeros, which is 10,000. This will be an 8 followed by 5 zeros, which is 800,000, I believe. This one here, 3 times 10 to the 8, it's a 3 followed by 8 zeros, which I think, it's hard to think of them out loud, or I think it's 30 million, I'm not all the way sure. And 7 times 10 to the 1, that's ridiculous they've written it that way, because it's just 70. Cool. Write these numbers in standard form. 4.3 times 10 to the 4, 5.61 times 10 to the 5, 5.6 times 10 to the 1, 3.47 times 10 to the 1, and 6 times 10 to the 1, or just 10. Cool? Next one, write these as ordinary numbers. This should be, I'm just going to say the digits rather than trying to say what the number is, because it'll be quicker, I think. This one here, it should be 396 followed by 2 zeros. This one here, it should be 68 followed by 6 zeros. This one here should be 8020. Next one should be 57. The next one after that stays the same, 9.23. Okay, here we go. There are 7 billion people in the world. Write this in standard form. 7 times 10 to the 9. Cool. The circumference of Earth is 40,000 kilometers. Write this number in standard form. 4 times 10 to the 4. And you've got it. Cool beans, buddies. Now, that's not even half of it, buddies. We have just done it for enormous numbers. So you're thinking about galaxies, thinking about space, even thinking on Earth sometimes you'd want to use numbers that are in standard form as well. There's lots of reasons to use standard form numbers. Now here's where we get really intense. Do you know it works for small numbers too? So in the same way that scientists don't want to write out millions and millions and millions of zeros at the end of a number, if I said to you, I don't even know how big an atom is, but say I said to you, I'm going to try to make it up. Watch me guess and see if I get it right. Okay. Oh, you're going to have to Google and correct me, but here we go. Say you want to figure out how big an atom is. I think it'd be something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, oops, 0, and then, I don't know, 2 or something meters big. That's how I bet you that's how I bet you one atom is. Like, I think that I've got that there. What would that be? That'd be millimeters, and then we'd be like micrometers, then we'd be nanometers. Oh, I don't even know actually. But anyway, you get my point anyway, that you don't want to write millions of numbers in front of something, okay? You don't want to be like tons and tons and tons of zeros. So essentially, yeah, we gotta have a better way of writing it. Now, we can still use regular old standard form on these decimal numbers. So if you look at this one, 0.0034, we're going to do the same thing as we did last time. We're going to start off by writing 3.4, because we need one whole number, then a decimal, and then whatever's left. And this is going to be times 10 to the power of, but you see how it's a small number. Because it's small, we're going to go minus 3. Okay, 1, 2, 3 that way to get it there. And it's going to be minus 3 because the decimal has to move to the right to get it to move there. We're talking about small numbers. There'll be negatives here for small numbers. So similarly, this guy here, well, the number for sure is 6.54 because you want the decimal to be after the first one. And how many steps are there? Well, 1, 2, 3, 4, 5, 6. So it's times 10 to the minus 6 when you move the decimal. This one here is a bit funnier because there's a 0 after the 3 also, but it's 3 point, and don't let it fool you, there is non-zeros down here too. So 0033, you copy out that whole bit after the decimal, and it's times 10 to the minus 2 or the plus 2. Let's say a minus 2 to indicate it's a small decimal number, to indicate that you're going to move the decimal the wrong way. You're going to move it to the left of the decimal point from your answer. Cool. I forget why. Oh yeah, these are just because they're the opposite, so I've done them in red. So what do we get here? 4.65 times 10 to the minus 2? Well, is it going to be a bigger number and be 465? Because it'll go once, twice. Or, because it's minus, is it going to become a small number and we'll go twice this way? Well, yeah, you're right. Twice to the left. So here we go. Move it twice to the left. Once to get it in front of a 4. And then once to get a place holding 0. So it'd be 0 point, place holding 0, 465. Now if you want to see it with placeholders, here it is, once, twice, so the decimal winds up there. You're going to pop your place holding 0 in there, and a 0 at the front to make it look pretty, and that's how come we got the same answer. Cool beans? What about this last one then, buddies? Well, check it out, we got to move it 4 times. So if we moved it once to here, there's going to be 3 more gaps. So 0.0003243. Bish, bash, bosh. And just the same way as before. Once, 2, 3, 4, which means you need 1, 2, 3 placing while holding zeros, and another one in front. Cool beans. Well, oh, there's the bell. There's the bell going. I guess you do feel like you're in school today then, don't you? Yeah. Okay, so there you go. You actually heard the bell. How exciting. It feels like you're here. Okay, so here's what we're going to do. Quick as you can. I want you to race through these bad boys again. Same deal as before, but this time writing them in standard form. Do them as quick as you can. You should pause the video so that you can do it. And are you ready? 3, 2, 1, go. And you are back. Okay, my buddies. So, check it out. 5 times 10 to the minus 3. Give yourself a tick if it's right. 4 times 10 to the minus 2. 7 times 10 to the minus 3, 4, 5, 6. 7 times 10 to the minus 6. 9 times 10 to the minus 1. 8 times 10 to the minus 4. This one here. You should have 0.4 zeros and then a 6. This one here you should have 0.08. This one here you should have 0.6 zeros, then the 5. Then this one should be 0.3. This one should be 0.7 zeros and then a 1. Here you go. 4.7 times 10 to the minus 3. 9.8 times 10 to the minus 1. 8.034 times 10 to the minus 4. 1.5 times 10 to the minus 4. And 6.01 times 10 to the minus 1. Here we go. 0.40 is 843. 0.0201. 0.6 zeros, 42. This one here, 0.7854. Next one, 0.3 zeros, 94. Here we go, standard form the other way. Ooh, it's a big one just to throw us off. 4.57 times 10 to the positive 5 this time, so it's a big one. 2.3 times 10 to the minus 3. 3 times 10 to the minus 4. 2.356 times 10 to the 6. 7.82 times 10 to the minus 1. 8.9 times 10 to the 4. 2 times 10 to the 2. 5.26 times 10 to the minus 3. 6.034 times 10 to the 3. And 8.73 times 10 to the minus 6. Whew, exhausting. Here we go, right? These are ordinary numbers. 0. Oh, I've just about had enough of them now, have you? 0.3 zeros, 412. 3 with 3 zeros, 3,000. 2. Oh, here we go. 2065 and then 4 more zeros. Here we go. 0.5 zeros and a 4. 3, 2, 7 and then 6 more zeros. This one here, 0.75. This one here, 156.23. This one here is 0.6 zeros, 512. Then we've got this one here, 2, 7, and then 4 more zeros. 2, 7, and then 4 more zeros. This one here is 0.612. Whew, okay. A micron is 0. Blah, 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 blah of a meter. Write down the size of microns in meters in standard form. 1 times 10 to the power of minus 6, it looks like. A particle of sand is diameter that. Write this number in standard form. 6.25 times 10 to the minus 2. Whew! Boom, my lovelies. The lesson is through. I hope it's okay. Please ask me questions on Show My Homework, or on Show My Homework, or on the video, or whatever. It's all good. And that's a paramecium, which is a cool thing. I remember thinking they were awesome when I got to look through a microscope on them. And that's a particle, or it's a DNA, that is. That's really cool. Cool. So here's what I'm going to get you to do, my buddies. I've attached a puzzle, which looks like this, okay? So you don't have to do it on the screen, so don't feel panicky about pausing the video. It's attached to Show My Homework. And all you have to do is complete this puzzle. I'm going to show you how it works real quick, and then I'm going to leave you to it. So you start here clearly where it says start, and you go through T, so you're going to jot down T, that's the first letter, and it's got 6.4 times 10 to the 4. Now, you guys know that that means it is going to be 6, 4, and then to get it once there, and there's 3 more moves, so 1, 2, 3. 64,000, which you'll find matches up to here. And then you go down. See what I mean, buddies? So the second letter is an H. Then you would do this one. 3.2 times 10 to the 3. Well, what does 3.2 times 10 to the 3 make? Well, move the decimal once to get it there. 2 more zeros, so it's 3, 2, and 2 more zeros. So 3,200. You find that one, which is going to be 3,200 somewhere in this mess. 3,200. And where is it? Where is it? Somewhere. Well, I put myself under too much pressure trying to do it in front of you. Oh, there it is, found it. Okay, there you go. And boom. So the next letter is E. Cool? So the something maybe, unless that word continues. I want you to finish off the whole puzzle. Take a picture of it all done with the answer clearly figured out and stuff. And that's it from me. So see you next time. Bye, lovely Super 9s. Bye, buddies.